Bismillahirrahmanirrahim. Today we'll be solving question number 5 of Canadian Professional Engineering Technical Exam, December 2019. And this is a very simple question. We have to solve the circuit to find V0t, that is the voltage across the capacitor, by using superposition theorem. So I hope you have some idea what is superposition theorem. In superposition theorem, we solve the circuit by using one source at a time, and then we add the results to find the final result. So like this V0t, for the first source, let's call this source number 1. Due to this, whatever voltage will be here, we'll call it V1. And due to the second source, whatever voltage will be here, we'll call it V2. And the sum of the two will be the total voltage. Okay, so let's consider the left source first, and we put the other source 0. And I hope you know that the voltage source is made 0 by short circuiting. So we short circuit the voltage source, it has become 0, and now we'll solve this circuit. And for ease, we convert the circuit from time domain to phasor domain. So as far as the current source is concerned, we have to identify from here what is omega. So you can see omega is 20. So we'll write omega is 20 radians per second. And then we'll convert the inductor and resistance. Inductor, I hope you remember, we write it J omega L. So J omega 20 and L is 2. So inductor will be replaced by J40. Similarly, capacitor is replaced by 1 over J omega C, 1 J omega 20, and C is 0.5. So this is the capacitance in phasor form. And the source, we just take the magnitude and the angle if it is in cosine form. So we're just taking 5 and the angle 10. And now we'll draw the equivalent circuit in phasor domain. So this is the equivalent circuit. We have replaced this by the this value, and replaced capacitance and value of inductance as well. And now the aim is to find this voltage here. Now if you look at the circuit carefully, the current is flowing from here and up to this point, no problem. But here it has 3 paths, 1, 2, and 3. So the current will take the easiest path, and the easiest is the short circuit path, no resistance. So all current will flow through this path, and no current will flow in this or in this. And there is no current flowing, capacitor will not be charged, so the voltage across the capacitor will be 0 volt. So since all current will flow through the short circuit and no current will flow through the capacitor, and the capacitor voltage V1 is 0 volt. So that is the first part. Now let's go to the second part. Now we'll make this 0 and use the second source. So to make current source 0, we open it. And since here also omega is 20, therefore we'll use the same values that we calculated earlier. And there is one point. This is in sine form. To make it in phasor form, we have to convert it into cosine form. And in my class, I had used this technique that if we are going from cos to sine, that is S to S, or same to same, then you add 90. Now here we are not going same to same, we are going from sine to cosine. Therefore, logically, we should subtract 90. Okay, now if you don't remember this, no problem. There is a simple technique. Use your calculator and you write first of all sine and take any angle. So I'm taking 30. Sine 30 is equal to half. And now we'll take cosine 30. Now the question is whether we add 90 or subtract 90. So let's first of all see what is happening if we add 90. So plus 90 equals minus half. So it's not the same. That means we cannot add 90, so we have to subtract 90. Okay, and now let's see the answer. So it is same, half. Therefore, from sine to cosine, you have to subtract 90. Okay, so 10 sine 20t will be 10 cosine 20t minus 90. And now from cosine terms, we can write directly in phasor. So it will be 10 angle minus 90. So we'll replace this here and replace the inductor capacitor with the values. So this is the phasor circuit. And this voltage actually it should be V2T. V2, not T even, V2. Okay, so now if you look, this voltage is 10 angle minus 90, and these are all in parallel. So same voltage will be here and same voltage will be here. So we can say that V2 is 10 minus 90. And now the sum of the two, V0 is V1 plus V2, 0 and this value. So in phasor, V0 is 10 minus 90. Now the answer required is in time domain, not phasor domain. So we'll convert this into the time domain. And since this is magnitude and this is angle, so we'll write 10 cosine omega t, omega is 20, so 20t minus 90. So this is our final answer. So I hope you have been able to follow this. Thank you.